Hey guys, today we are going to be integrating using partial fraction decomposition. So to introduce this to you, let me start off with just a little bit of an intro integral. Let's say that we have this integral. Let's say that we have 1 over something like this, dx, that integral. So at first glance, so the degree of the denominator is larger than the degree of the numerator, so we know that we cannot go and divide. We can try to u sub the bottom, but there's no x on top to take care of the du that we would get. So then you might think, well, maybe we should complete the square. If we try to complete the square on this, the denominator will be, we would write that down, right? And then we would add half of 6 squared, which would be a 9. The problem is we had 5, and now we just added 9. So to keep our value of 5, we would have to subtract 4, right? That little guy right there ruins the chance for this to be an arctan. So this, if we tried it that way, it would look like this. It would look like that, right? That minus, not an arctan. So in this one, we would not complete the square. Instead, we observe that the denominator can be factored, and so that's the rep. That's what we're going to use for this. So when we do partial fraction decomposition, when we do that, here's what we're doing. What would you do to add these two fractions? What would you do to add those two fractions? To add those two fractions, you would get a common denominator, right? The common denominator would be the product of those two denominators, x plus 2 times x plus 3. And then we would multiply this one times the x plus 3 plus this one times the x plus 2, right? That's what we would do, and we would get 2x plus 5 over x plus 2 times x plus 3. That's how we add fractions, right? Add rational expressions together. So this would be, if we multiplied out the denominator, we would get that, right? So that's all well and good when we're adding rational expressions together. The problem is, not the problem, but observe that if we started with this, what does it take to do to get back to this? Because this looks a little bit like what we started with in our integral. If we're integrating this, we need to get back to that. These are the partial fractions that make that. So that's what we're doing here. That's what we're doing. We're going to go through the process that allows us to break apart the two factors in the denominator. So when to use this? You have a rational integrand. The degree of the numerator is less than the degree of the denominator. Less than. In other words, bottom heavy, bottom heavy, bottom heavy, all right? And the denominator can be factored. That is key, all right? If it cannot be factored, try to complete the square. Or do a u sub, of course. All right, so for number 1 here, the first thing I'm going to do is to rewrite this in factored form. So we're going to use the Algebra 1 technique of factoring this denominator. So x plus 5, x minus 5, or x minus 5, x plus 5, right? Great. So now that I have written it like this, and the degree of the numerator is less than the degree of the denominator, I know that I can write this as something over x plus 5 plus something over x minus 5. I just need to find out what those two somethings are that make this thing add together to get this thing, right? I do know that these numerators will just be numbers. I do know that there will not be x's in here, okay? So that's true because of the degree of 1, these denominators are linear, and if the denominators are both linear, you're not going to have an x up here. There's no way that would add together to get 10. All right, so we're going to go through the process. I'm going to come up here, this side, up here, and I'm going to start with, you know what, I might just come down here. It might take a little bit more space. I'm going to come down here. So I have the 10 over x plus 5, x minus 5 is equal to something over x plus 5 plus something over x minus 5, right? So we need to label these something to give us something to work with. I'm going to label it an A and a B. That might look familiar to you from pre-calculus. This is what you did in pre-calculus. All right. So I'm going to begin by multiplying both sides of the equal sign by the common denominator, by the x plus 5, x minus 5. If we multiply both sides by x plus 5, x minus 5, on the left-hand side, we're going to be left with just the 10. The denominator will completely cancel out. Over on this side, if we multiply this whole side by x plus 5, x minus 5, this x plus 5 will cancel with the x plus 5, leaving the x minus 5 times a. So this will be a times the x minus 5. For this term, the x minus 5 will cancel with the x minus 5, and we'll be left with the x plus 5 times the b. At this point, we're going to let x be something that is going to allow us to find either a or b. Because remember, we're looking for these numbers. So we can let x be anything that we want, and what is a convenient value to let x be would be either positive 5 or negative 5. And that's what we're going to do. If x is positive 5, then on the left-hand side, we have 10 still. On the right-hand side, this a term zeroes out, and we have b times 10, which means that b must be 1. So now we know b, the number that's over the x minus 5, is 1. Now we're going to find the a term. To find the a term, I'm going to let x be negative 5. So we're going to let x be negative 5. If x is negative 5, we have 10 on the left. We have a times negative 10 plus 0, and that means that a must be negative 1. So now we know that the number that is on in the numerator of the x plus 5 term is negative 1. And that's the hard part. Now all that is left is to integrate this, and these are easy to integrate because the denominator is linear. All we need to do is say, okay, this is negative 1 ln absolute value x plus 5 plus 1 ln absolute value x minus 5. Since both of these had a coefficient of 1 on their x's, when you do a u sub, you're not going to get anything else out in front, right? It's like we're dividing by 1 out here, okay? Plus c, and we're done. Now, that's how I would end this problem. That's how you're going to end these today. Next week, though, we're going to have boundaries on this guy. Next week, when we do improper integration, we're going to have boundaries, and we might have a boundary that is a 5 or a negative 5, or we might have a boundary of infinity. For those problems, we're going to want to combine these logs. We're going to want to combine these before we plug in values. We're going to want to do that. It's going to make it easier for us. Sometimes it's going to be absolutely necessary to do it. So let's combine these to make a single log. Since this log is negative, its argument would go in the denominator. Since this log is positive, its argument goes in the numerator. So we'll have x minus 5 over x plus 5. I'm really squeezing this in. Okay. And then they both had an absolute value, so I'm just going to put absolute values around the whole thing. Those are still necessary. If you put it around the whole thing, that means the absolute value of the top over the absolute value of the bottom. So we're going to want to do that next week when we have improper integrals. Let's take a look at number 2. So the degree of the bottom is greater than the degree of the top, and the bottom is factorable. So we are going to use partial fraction decomposition. Step 1 is the Algebra 1 step of factoring. So this factors into x and x, 3 and 4, and they have to both be negatives to get that plus 12 and the negative 7. So yes, it works. Take your time, make sure you factor correctly. If you don't, your whole thing is wrong. Okay? So now I'm going to write this as something over x minus 3 plus something over x minus 4. Excuse me. We just need to find out what those two somethings are. So I'm going to come off to the side and find out. So I'm going to rewrite this thing, 4 minus 2x over x minus 3 times x minus 4 is equal to something over x minus 3 plus something over x minus 4. Need to find out what those two somethings are. When we multiply both sides by the common denominator, on the left-hand side we have just 4 minus 2x. On the right-hand side we have a times the x minus 4 plus b times the x minus 3. What is a convenient value of x in order to find either a or b? Well, if we let x be 4, we'll be able to find b. So I'm going to let x be 4. 4 minus 2 times 4, that's 4 minus 8, that'll be a negative 4, is equal to 0 plus b times a we're letting x be 4, right? Did I do that right? Yes. Yes. Okay, we're letting x be 4 here, so that's a 1. So this gives us that b is negative 4. So b, the number that was over the x minus 4, make sure you get that in the right spot. That was our negative 4 right there. The other convenient x value to let x be would be 3. If we let x be 3, we have 4 minus 6, that's a negative 2. And that will be a times a negative 1 plus 0. That means that a is 2. A is 2. The hard part's done. Now we just have to integrate. So this will be 2 ln absolute value x minus 3. Again, the coefficient of the x is 1, so when you do a u sub, you're just going to get a dx, so that you don't have to divide this 2 by anything. Minus 4 ln absolute value x minus 4. The derivative is 1. It's like we're dividing by 1. Plus c. And we're done. Again, next week we're going to want to combine those. Let's combine these one more time. I won't do that for the other two examples. But if we're combining these, what do we do with the 2 and the 4? We have to get those. We have to get rid of those. We have to do something with that before we write the single log. So I'm going to write this as ln absolute value of x minus 3 squared, or you could just square the x minus 3, right? Either one is fine. Square the whole argument or just square the inside, either one is fine. Since it's a square, do we really need the absolute values? No, we don't really need those. Does it hurt to have them? No, but we don't need them. Oops, I'm moving the 4 to the exponent, right? And again, it'll be x minus 4 to the 4th. With that 4 as a power, this thing will never be negative, so we really don't need the absolute values. It doesn't hurt to have them, but we just don't need them. Now we can write this as a single log. X minus 3 will be in the numerator. X minus 3 squared will be in the numerator because it is with a positive log. The x minus 4 will be in the denominator because it is with a negative log. plus c, and we're done. Okay, I didn't write the absolute values there at the end because we just didn't need them, but if you want to write them, that doesn't hurt. All right, let's do another one, number 3 here. So the degree of the denominator is larger than the degree of the numerator. It is bottom heavy, and the bottom can be factored. So we're going to use this technique. But before we do that, I'm going to do something else to make it more pleasant for me to factor. I like to have a positive coefficient for my x squared term. So I'm going to multiply top and bottom by a -1 to get rid of this negative in front of the x squared term specifically. So in the numerator we'll have an 11x plus 1. In the denominator I'm going to move this to the front, so it's going to be a positive 3x squared, a negative 2x, and a -1. Perfect. Much easier on my eyes to factor. So we're going to take our time, factor right. We are going to have a 3x and an x to get the 3x squared. This is a 1, so I'll have a 1 and a 1. And to get this -2, I know that we're going to have different signs. To get the -2, I'm going to need the minus back here to multiply by the 3x, and the plus here to get that positive 1x. So make sure that you factor correctly, you guys. That's the Algebra 1 step, so make sure you get your Algebra 1 right. Okay, and I just was going to rewrite the same thing. Forget that. We're going to need something over the 3x plus 1 and something over the x minus 1. Got to find out what those two somethings are. Going to go off to the side. 11x plus 1 is equal over the 3x plus 1 times the x minus 1 is equal to something over 3x plus 1 plus something over x minus 1. Okay. Multiply both sides by the common denominator. Yep. Okay. I always get students, Miss Murray, can I just start with this? Do I have to write this out? And the answer is no, you do not have to write this out. You can start with this. But remember, in the end, the thing that I find some students who do that, some do this and do it great, and that's fine. But some students, when they find a, they want to put it over the x minus 1, and that's not true. If you begin by writing this step, then the a needs to, in the end, when you find a, it needs to go over the 3x plus 1, not the x minus 1. So be careful with that. Other than that, just go for it. I'm going to start with letting x be 1. If I do that, on the left-hand side, I'm going to have 12 is equal to 0 plus b times 3 plus 1 is 4. That gives me that b is 3. So b is 3. Okay. Now, for the next step, I could let x be -1/3. If I do, I'm going to have to deal with fractions though. So instead of letting x be a -1/3, I'm going to let x be 0. Why? Because 0 is pleasant and I have already found the value of b. So I can put 3 in for b when I put 0 in for x here, and it'll be fine, alright? But putting -1/3 in for x would work equally well. So that's fine if you want to do that. Alright, so when I put 0 in for x, I'm going to get 1 on the left, and that's going to equal a times -1 plus b, which is 3, times 1. So I have -2 is equal to -a, which means that a is 2. So a is 2 there. Alrighty, so now it's integration time. 2 ln absolute value 3x plus 1. What is the derivative of the 3x plus 1? The derivative of 3x plus 1 is 3. So we have to divide by that 3. That's what we would get if we took the time to do a u sub. Alright? To me, this is a quickie u sub. An easy u sub. The derivative is 3. Undo the 3. plus this 3, ln absolute value x minus 1. The derivative is 1. It's like we're dividing by 1. Plus c, and we're done. One more, and honestly, if you're watching this video, if you want to stop right now, you have my blessing. All right? Okie doke. But if you're hanging in there with me, I'm going to rewrite this as negative 8x minus 2 over, I'm going to factor out an x, and then I'm going to continue to factor that denominator, x and x, 2 and 1, and this 2 needs to be a negative, like that. Like that. So we're going to have 3 fractions here, something over x, something over x minus 2, something over x plus 1 dx. Okay? Got to find out what those some things are. So I'm going to come off to the side. Alrighty, negative 8x minus 2 over x minus 2, x plus 1 is equal to a over x, b over x minus 2, c over x plus 1. Multiply both sides by the common denominator. Oh, the a will need to be multiplied by the x minus 2 and the x plus 1, right? The b will need to be multiplied by x and x plus 1. The c will need to be multiplied by x and x minus 2. Got 3 convenient x values. When x is 0, we're going to have negative 2 is equal to a times negative 2 times 1 is negative 2. This term, the b term will zero out, the c term will zero out. So we get that a is 1. A is 1. Another convenient x value is 2. When x is 2, we'll have negative 16 minus 2, that's negative 18, is equal to, the a term zeroes out, b times 2 times 3 is 6, the c term zeroed out, b is negative 3. b is negative 3. Last convenient x value will be a negative 1. When x is negative 1, we have 8 minus 2, which is 6, and that's equal to, the a term zeroes out, the b term zeroes out, c times negative 1 times negative 3, negative 1 times a negative 3 is 3, so we get that c is 2. c is 2. Integration time, and we get ln absolute value x minus 3 ln absolute value x minus 2 plus 2 ln absolute value x plus 1 plus c. And we are done. We are done. In class, we also did together on this homework, number 5, part A. We did that together. But anyway, okay, that's it. That's it for partial fraction, integrating with partial fraction decomposition.